Welcome to Understand the Math. In this video, I'm going to walk you through examples of finding powers of complex numbers. Our first step is to find r. r is the square root of a squared plus b squared. And this is equal to the square root of 1 plus 1, which is equal to root 2. Our second step is to find theta. We notice that 1 plus I is in quadrant 1, so theta is equal to the inverse tan of b divided by a. This is equal to the inverse tan of 1, and we know that the tangent of pi over 4 is 1, so our angle theta is equal to pi over 4. Our third step is to apply our formula. Z to the n is equal to r to the n times cosine of n theta plus I sine n theta. And let's make a note that for our problem, n is equal to 6. This gives us 1 plus I to the 6th is equal to r, which is root 2 raised to the 6th, times cosine 6 times theta, which is pi over 4, plus I sine 6 times pi over 4. Our last step is to simplify. We have 1 plus I to the 6th. The square root of 2 raised to the 6th is 8. And then we have cosine 3 pi over 2 plus I sine 3 pi over 2. Cosine 3 pi over 2 is 0, plus I times sine 3 pi over 2, which is negative 1. This gives us a final answer of minus 8i. Let's now look at our second example. Our first step is to find r. r is our square root of a squared plus b squared. r is equal to the square root of minus 2 root 3 quantity squared plus minus 2 squared. This is equal to the square root of 4 times 3, which is 12, plus 4. So this is equal to square root of 16, or 4. Our second step is to find theta. We notice that our complex number is in the third quadrant. So theta is going to be equal to pi plus our reference angle theta sub r. Theta sub r is the inverse tan of the absolute value of b divided by a. So this is inverse tan of the absolute value of minus 2 divided by minus 2 root 3. This is equal to inverse tan of 1 divided by root 3, which we know is equal to pi over 6. Our theta then is equal to pi plus pi over 6, which is 7 pi over 6. Our third step is to apply our formula. We have z to the n is equal to r to the n times cosine n theta plus I sine n theta. And let's make a note that n is equal to 5. This gives us minus 2 root 3 minus 2i raised to the 5th is equal to r, which is 4. So we have 4 to the 5th times cosine. Our n is 5. Our theta is 7 pi over 6. So 5 times 7 is 35. So we have 35 pi over 6 plus I sine 35 pi over 6. Our fourth step is to simplify our calculation. The first part that we'll do is simplify 35 pi over 6. Since this angle is greater than 2 pi, we'll start by subtracting 2 pi from it. We have 35 pi over 6 minus 2 pi, and that gives us 23 pi over 6. That also is greater than 2 pi, so let's subtract 2 pi again. And that gives us 11 pi over 6, which we can use because it's between 0 and 2 pi. We have minus 2 root 3 minus 2i to the 5th. Hang with me, we're almost done. This is equal to 4 to the 5th. 4 to the 5th is 1024. And then we have cosine 11 pi over 6 plus I sine 11 pi over 6. This is 1024. 11 pi over 6 is in quadrant 4, and the reference angle is pi over 6. So cosine 11 pi over 6 is root 3 over 2 plus I sine 11 pi over 6. It's going to be negative, and we get a minus 1/2. 2 goes into 1024, 512. So we get 512 times root 3 minus I. So our final answer is 512 root 3 minus 512 I. I would suggest that you do a few more problems to get comfortable using this formula. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.